Epilogue, the missing distribution. At this point, by the very end of this course that has taken you on an overview of distributions and techniques to selecting an appropriate one, you may probably be wondering about a missing distribution. You guessed it, the normal or Gaussian distribution. It is impossible to have taken Stats 101 in college without the ubiquitous presence of the normal distribution. I'm always amazed by the number of risk practitioners who assume that a normal can be fitted onto every single type of phenomena. By the way, already in the 19th century, the term for discovering a normal distribution in places where it did not exist or that failed to meet the conditions had already been coined as catalytismus, honoring the Belgian mathematician who sought to discover it everywhere. In an extreme position, Nassim Taleb, the author of the bestseller The Black Swan book, is a harsh critic of its usage, even daring to only referring to it as the great intellectual fraud. Overwhelmingly, the normal distribution is an important one in statistics and is often used in the natural and social sciences to represent real-valued random variables whose distributions are not known. Its importance is partly due to the central limit theorem. This theorem states that, under conditions of independence of the parts, the average of many samples of a random variable invariance is itself a random variable whose distribution converges to a normal distribution as the number of samples increase. Therefore, physical quantities that are expected to be the sum of many independent processes often have distributions that approximate to normal. Insisting on the previous central limit theorem, essentially you should check for two requirements for an appropriate usage of a normal distribution. First, the normal distribution is used for phenomena that are the sum of somewhat homogeneous elements. That is the reason why it can be widely utilized for measuring errors in manufacturing or agricultural processes, or in polling, since its conclusions are drawn from adding together atomic or individual parts. The second condition you need to check is on the independence of each one of the summing parts. If you are adding together individuals that are closely dependent from each other, the rule of independency will exclude a proper usage of the normal. For example, given that the duration of a project is the sum of all the duration of the activities on the critical path, you cannot state that the total project duration is normal, since each activity's duration depends from the previous activity's durations. The rule of independence is therefore violated. Exercise 17. Normal and lognormal distributions. On cell B146, we will arbitrarily sum, with no concluding purposes, the variables on cells B24, B53, B58, B64, and B67. There are two perts, one extreme value, one uniform, and one triangular distribution. Sum them all together on this cell and declare the cell as an output with the name sum normal. Now, on cell B147, we will arbitrarily multiply these same cells with no concluding purposes. The variables on cells B24 times B53 times B58 times B64 times B67. When you have multiplied them all, declare the cell as an output with the name product lognormal. Now, proceed to run a simulation with 10,000 iterations. In practical terms, you should look for independence of the components and whether the analyzed process is either composed as an addition. In this particular case, the normal distribution fits well. By the same token, if a process is multiplicative, such as in biology or in the extraction resources industry, it can be demonstrated that a log-normal distribution is the adequate fit. On top of cell B146, browse its results, you will see a distribution that looks like this. On the Settings button, click on the Fit Output option to fit these 10,000 data points. Click OK when this next window appears. Your data points will be adequately fitted to a normal distribution. On top of cell B147, browse its results. You will see a distribution that looks like this. On the Settings button, click on the Fit Output option to fit these 10,000 data points. Click OK when this next window appears. Your data points will be adequately fitted to a log-normal distribution. Conclusively, you can observe how a sum of independent random values that are not necessarily normal, some of them were paired, triangular, uniform, ended up converging onto a normal distribution because their relationship was additive, and each one of the distribution components were independent. In other words, there was no correlation between them. By the same token, you can observe how a multiplication of independent random values that are not necessarily normal, some of them were paired, triangular, uniform, ended up converging onto a log-normal distribution because their relationship was multiplicative and each one of the distribution components were independent. In neither case, the two mentioned distributions, the normal or log-normal, fitted as the first choice according to AIC. This is no fair justification for exclusion as a valid distribution. On our coming trainings on advanced fitting options, we will come to the topic of hypothesis testing, where these issues will be discussed.